Good morning, everyone, and welcome to Climate Week, part of the Center for Planning Excellence's annual Smart Growth Summit. I'm Camille Manning-Broome, President and CEO, and I'm so glad you're with us. We are incredibly excited to kick off Climate Week with this stellar group of speakers, and we look forward to a thoughtful conversation about the future of Louisiana, but grounded in some hard realities about our changing climate, but hope for a sustainable, equitable, and prosperous future. Today's session, the first session of the Summit's Climate Week, is titled, "It's Time to Define the New Normal, Dr. Michael Oppenheimer on Our Future Climate." A few housekeeping items to address before we get started. Today's session has been pre-approved for continuing education for certified planners and certified floodplain managers. If you're a certified floodplain manager, please fill out the survey that will appear when you close the Zoom window so that you can help get continuing education credit. Realtors, architects, landscape architects may self-report credit. Please visit the continuing education tab at our website, summit.cpex.org, for more information. You may turn on closed captioning using the button at the bottom of your screen. First, we will have some opening remarks. Then we will hear from Dr. Oppenheimer, followed by a discussion with our panelists. We have reserved the final portion of this session for a panel discussion, including questions from you, our viewers. Please enter your questions for our speakers into the Q&A chat using the button at the bottom of your screen. And finally, we are recording this session, and all registrants will receive an email with the video link after the session. But before we get started, I'd like to thank our sponsors, especially our platinum sponsors, Blue Cross Blue Shield of Louisiana, Greater New Orleans Foundation, Power Coalition for Equity and Justice, and 89.3 WRKF. And our gold sponsors, American Planning Association Louisiana Chapter, LSU Ag Center, and the Nature Conservancy. Closed captioning is provided by AARP Louisiana. Without their support, CPEX would not be able to bring expert speakers like those featured in today's session to our summit participants. Their leadership helps us elevate the planning issues that will define our future. So first, I'd like to provide some opening remarks and what this conversation means to me. Louisiana is a very special place to me, and it is also so critical to our nation. Some of the United States' most vulnerable and natural resources and ecological systems are found right here in Louisiana. And our unique cultural heritage and amazing diversity of fun-loving, hardworking people make Louisiana a national and global destination and a truly special place to live. Louisianians also share a beautiful sense of community. We take care of one another and we keep our loved ones close. My parents live on Toledo Bend. I grew up in Baton Rouge and spent my childhood exploring places like Paso Lutra, Point of Shen, and Rockefeller Refuge, all places that will be underwater in my lifetime. I would love nothing more than to have my two sons build their careers and families in Louisiana as well. But I worry about their future, knowing that the choices we make today will determine the prospects for my children, my grandchildren, and yours. Louisiana is on the front lines of climate change. The same land that provides such rich resources and is home to our families and communities is facing tremendous challenges. Our coastal communities have been adapting their homes, their businesses, and their lives to a changing environmental condition for decades. Communities across our state are now dealing with shifting weather patterns that bring a host of new problems: drought, more frequent and more severe storms, and increased rates of inland precipitation. Future projections indicate that sea level rise, increasing heat, and high humidity will make some places in Louisiana unlivable. All of these challenges are made more complex by long-standing disparities in race, income, and health, which are consistently laid bare by disaster, as we have seen most recently with the COVID-19 pandemic. We simply cannot plan for a future that provides safety, wellness, and opportunity for all of our residents without understanding climate change and its impacts. We cannot plan for communities that meet the needs of our people without understanding how those needs are shifting as climate change alters our environment and economy, especially within low wealth communities and among people of color. We cannot continue with siloed approaches to governance that don't effectively foster collaboration and coordination. We also cannot continue to rely on disaster dollars and one-time funding sources to finance the investment required to make Louisiana sustainable. We have to love our state and our people enough to invest in our own future and raise the resources we will need to adapt and mitigate climate change impacts. We must be clear-eyed and committed as we plan for our future. And as you will hear from Dr. Oppenheimer, we are right now, not 10 or 50 years from now, but right now at an inflection point. Drastic actions are needed immediately. But there is also great reason for hope. We can choose a livable future for Louisiana. Strategies for mitigating and adapting to climate change are available to us, but we must have the will to implement them. Opportunities for shifting our economy to be prosperous and sustainable are plenty. We just need the courage to seize them. And reducing the disparities that have left our most vulnerable to bear the brunt of these challenges is possible, but we must first value our collective humanity and recognize our shared future. That is why we are here today. We want to have a real dialogue with all of you. It is imperative that at this moment, we all know and then do. We are bringing you the most current climate science and experts who know what needs to be done to realize an equitable and sustainable future for our state and for our people. We must take bold measures, and it is incumbent upon all of us to act based on our knowledge of what the future holds. This work has never been more urgent for planners, city designers, engineers, legal minds, elected officials, or policymakers. Your presence here is a testament to the growing ranks of people from every walk of life and every sector who are committed to securing a stronger, more viable future for Louisiana communities. More than 50 years ago, Senator Robert Kennedy said that the work of change, no matter how challenging, can send forth a ripple of tiny hope. And that tiny ripple, joining forces with others from a million different centers of energy and daring, can build a current that can in turn change the world. We may not change the world today, but we can make a difference. We are each part of something larger than ourselves, a movement to ensure we build a future of inclusive opportunity and hope for communities big and small. So thank you for being a ripple of change and for joining our 15th annual Smart Growth Summit. The summit is a cornerstone of CPEX's commitment to delivering solutions for Louisiana by providing the opportunity for local leaders, practitioners, and activists to learn from and engage with experts and the range of disciplines that work together to create equitable, resilient communities. And today we have brought to you the world's leading climate scientist. Now I would like to welcome our keynote speaker, Dr. Michael Oppenheimer. Michael Oppenheimer is the director of the Center for Policy Research on Energy and the Environment at Princeton School of Public and International Affairs, as well as the Albert G. Milbank Professor of Geosciences and International Affairs at Princeton University. He is a longtime participant in the Intergovernmental Panel on Climate Change, which won the Nobel Peace Prize in 2007. He was Environmental Defense Fund's chief scientist and serves as a science advisor in numerous capacities. So Dr. Oppenheimer, we'll turn to you to kick off this conversation.
Thank you, Camille. First of all, let me say that it's an honor and a pleasure to be invited. I only wish that we were able to be in the same room together, and that maybe sometime in the future I'll be able to join you under those circumstances. I want to say that I changed the title of my talk. Let me first get it up there so I can show you. This will take a second. I'm going to share my screen with you. Whoops. Just give me a second here. I'm having a little difficulty. Have I been? Yeah. Okay. Sharing the screen. Hang on. Okay. Will somebody give me a verbal signal as to whether you can see my screen now?
I can see your screen, Dr. Oppenheimer. Thank you.
Okay, good. Sorry for that little interruption. So the question isn't, are we going to talk about the new normal? The question is whether we'll ever reach a new normal. And in stating that, I'm stealing that from a colleague of mine, Dr. Michael Mann of Penn State University, who made the apt point that there isn't going to be a new normal that we can rely on for quite a while. We're in a world that's changing, where the climate is changing. So as soon as we get used to one climate, we're going to have to start thinking about what will happen in 10 or 15 years. So we're in a situation of permanent change. I want to use that as an introduction and tell you that what the order of my talk is going to be. First, I'm going to discuss the basic science of climate change from a global perspective, then speak about the impacts of climate change from a global perspective, and then focus down on Louisiana, what's going on here, and how it's kind of an indication of what's going to happen in a lot of other places, indeed what started to happen in a lot of other places as we go forward. So the basics of climate change are this. Certain gases that exist naturally in the atmosphere are transparent to sunlight. Sunlight warms Earth's surface. And then these same gases, called the greenhouse gases, trap some of the heat that tries to radiate back from the warmed Earth's surface into space. We know this for sure. There's no argument about it. It's basic physics. We also know it because if you see over here, Venus on the left is our neighboring planet closer to the sun, is much hotter than Earth. Most of that additional warmth is not due to its closer proximity to the sun. It's due to the fact that its atmosphere is chock-a-block with carbon dioxide, which happens to be one of the important greenhouse gases on Earth, the major human-made greenhouse gas. On the other hand, a little further away from the sun is Mars. It's very cold, average surface temperature, not 864 Fahrenheit like Venus, not about 55 Fahrenheit like Earth, but minus 80 degrees Fahrenheit. That's because its atmosphere is lacking in greenhouse gases. Particularly, it has essentially no water vapor in the atmosphere. Water vapor is a very strong greenhouse gas. On Earth, it's a natural greenhouse gas. Human activity is increasing the greenhouse effect. And we can see that over here. These are measurements that began in 1957 atop Mauna Loa volcano in Hawaii. The black curve shows you the continual increase from the late 50s until today. The latest measurement, 414 parts per million, or 0.04% of the atmosphere, which was a measurement in September, is quite a bit above the 315 parts per million, or closer to 0.03%, which was measured back in 1957 when these first began. And it's the highest measurement in a million years at least. And keep in mind that in pre-industrial times, that is, if you go back, to the 17th century, 16th century, etc., before this buildup began, carbon dioxide levels were, we believe, about 280 parts per million. By the way, I should show you this red squiggly line here reveals kind of interestingly that since this is a Northern Hemisphere station, it picks up the changes in photosynthesis in the Northern Hemisphere, with winter revealing higher carbon dioxide levels because a lot of plant matter has died, respirated, and decayed. Their carbon, plants are made largely of carbon, goes back in the atmosphere. Then during the summer, there's a lot of sunshine, a lot of photosynthesis. The carbon dioxide levels in the atmosphere are drawn down as plants build themselves. Sorry. Now, we have a much longer view, not just back over the last 50 or 60 years, not even back over just the last 100 or 200 years, but back thousands, tens thousands, and now the latest ice that's being analyzed is about 1 million years old. Turns out if you drill to the center of Antarctica, the center of Greenland, or in the middle of certain mountain glaciers, you can go down to ice that was laid down by snow that fell 100, 1,000, 10,000, 1 million. Now, some of the oldest ice is about 2.7 million years old. You can extract those ice cores, shave them off in a clean lab. They have a structure such that they have air bubbles in the middle, just like an ice cube does. Those air bubbles formed when the points on the snowflakes that formed the ice long ago got crammed together as the ice compacted, trapped air, and those air bubbles are virtually unchanged samples of the atmosphere as it stood when the ice was originally formed. Now, I've just got the top of one of those ice cores, which goes back here to 10,000 years on the left. 0 is the current time. You notice carbon dioxide levels were more or less constant, as I said, at about 280 plus or minus through that whole time. Maybe a little build up here due to human beings early on deforesting areas in Europe, for instance. But then you get to the recent times, the last 200 years, which is blown up here. You see the effect of industrialization with a large increase, a very rapid increase in the amount of carbon dioxide. And the amount of carbon dioxide is increased by about 50% over the 280 parts per million level that existed hundreds of years ago. The greenhouse, there we go. Wait a minute, problem there. You know, one of my slides disappeared on me. I'm not going to be worried about that, so I'll just tell you what it shows. Earth's temperature has warmed over the last 150 years or so, which is the length of time that we are able to have a believable, credible thermometer network around the world. And this figure here shows the difference between recent temperatures and late 19th century temperatures, with the warming distributed around the globe such that the red and brown areas are the warmest change over that time, and the white areas are areas that show little change. As the global average change has been about 1 degree Celsius, which, if I'm going to talk about changes in degrees Celsius a lot of the time, you multiply that by 2 roughly, actually 1.8, to get the change in Fahrenheit. So the global average change has been about 1 degree, close to 2 degrees Fahrenheit over the last 100 years or so. You can see it's not uniformly distributed. These warmings in the Arctic and in some of these mid-continental areas are rather remarkably large. Now, the thing you want to know about carbon dioxide, the major greenhouse gas whose source is mostly the burning of coal, oil, and natural gas, and secondarily some deforestation. That gas is very persistent when it gets into the atmosphere. It does not go away naturally, except very, very slowly. And a good analog, one that's frequently used, is to think about a bathtub. You can go into your bathroom and try this experiment after I'm done speaking. No, you got to stay around for the other speakers, let's say tonight. And the analogy is this. Here's a level in the bathtub. That level is maintained. You can maintain it at a constant level. You should try this experiment yourself by balancing the inflow, which I'm going to make an analogy with emissions of carbon dioxide into the atmosphere from tails, pipes, and smokestacks, and the outflow, which I'm going to make an analogy with the rate at which carbon dioxide dissolves in the ocean naturally, which is fairly slow. Therefore, I'm representing this drain as being fairly clogged. That's why you see the stopper, the old-fashioned stopper, leaning over the drain hole. And you can get this balance to occur with a more or less stuffed drain if you have a low enough flow. The level here is the level in the atmosphere. It's equivalent to concentration or amount of carbon dioxide in the atmosphere. So what humans are doing is this level is rising. The reason it's rising is this inflow far exceeds this outflow. If you want to bring it back into balance, you have to turn the inflow essentially to 0. That's how clogged the drain is. That's how slow the natural removal is. And that's our challenge. How do we get emissions down low enough so we're actually bringing the system back into balance? Now, you can look at this another way. You can run a model, a computer model of how carbon dioxide behaves in the atmosphere. And one thing you can do, in which scientists have done, is run this model through for the next 1,000 years. And imagine that over the next 100 years or 200 years, we keep carbon dioxide increasing at roughly the historical rate. Then when you get to around 2100, let's say, you shut everything off. You shut off all factories. You shut off all power plants. You stop using automobiles. You stop all fossil fuel combustion. You stop deforestation instantaneously. That obviously can't happen. It'll be a slow turnaround. So this is a cartoon of what we're really going to be able to do, maybe. But if you got up to, say, 600, 700 parts per million, look at the rate at which the carbon dioxide dissolves into the ocean, out of the atmosphere. It's very, very slow, such that when you get to 300 parts per million, you still have double the natural background of CO2. In other words, we are more or less stuck with the CO2 we're putting into the atmosphere and will put in over the next few decades while we bring this under control, hopefully. And that is, unless we can find an artificial way to remove the carbon dioxide from the atmosphere. That's something I'll get back at the end of the talk. Now, let me go to one of the impacts right away, and that's sea level rise. There are three, and you're familiar with the problem. Camille mentioned it already. Sea level rise occurs due to three reasons. Number one, the shrinkage of mountain glaciers as the atmosphere warms, the loss of ice from the large ice sheets in Greenland and Antarctica, which at their fringes are starting to disintegrate due to the warming. And like any liquid, warm water expands, so ocean water expands when you heat it. That means the first two causes here, the first two bullets, change the amount of mass in the ocean. The third bullet changes the volume of the ocean, even if the mass were constant. All three are operating. There are also some minor causes of sea level rise I won't mention. But we know very well what's going on with sea level rise, and we know that it's caused by human activity, just like we know with high confidence that the temperature change we've seen of 1 degree Celsius to 2 degrees Fahrenheit is largely caused by human activity. There are three kinds of evidence we have, three different independent measurements of what sea level has been doing. For the first, this goes back to 1700 here, it ends today. And you see that for the first few centuries, we have what are called proxies or indirect measurements of what sea level is. For instance, when sea level goes up or down, the coral reefs in the tropics try to keep up with a rising sea level, or if the sea level is falling and that they get exposed to the rays from the sun, the tops of them will tend to die. So if you drill into coral reefs and extract cores of coral, you can tell, because there are like benchmarks that have been naturally created, by how high sea level was in the past. And in that way, we know pretty well that sea level rose very, very slowly until the late 19th century and even beyond. And when you get, and here you have no rise essentially. Here you have a slight rise starting to reveal the effect of a little bit of global warming probably. And then you get an acceleration as you go through the 20th century. The next set of instruments that measure sea level rise are called tide gauges. You have several out here in off southern Louisiana's coast. The tide gauges are flotation devices that bob up and down with the sea surface, and they give us a good indication of what sea level rise was as you move through the late 19th into the 20th and into the late 20th century and into the 21st. Then at the very end of the 20th century, we started having satellite measurements. We've had 28 years of them now. They are very precise globally in extent. We get them by bouncing a laser beam from a satellite off the ocean. And those three measurements tell us this story, that the rate of sea level rise, this is in millimeters per year, don't try to convert it in your head. I'll even have difficulty if I do it. For the last two millennia, the average was very slow. Those are the paleoclimate proxies. Then for the 20th century, the tide gauge measurements, it picked up by a factor of 5 or 10. And then when you move over here to the satellite era, the rate doubled again. That's this bend in the curve. Sea level rise is accelerating. That's acceleration is due to human activity. But it's not just average sea level that we're worried about with this problem. It's the extra rise in sea level that occurs during extreme events. Extreme events are either big storms or they're especially high tides. Let me show you how that works. Let's say you have the normal tide level. Tide, of course, can drop to below the mean, to low tide or high tide. We add sea level rise on top of the tide, so it brings the sea level up higher. Then if you have a storm like this one, a low pressure system, for instance, in a hurricane, it's going to create a surge due to the action of the atmosphere on the ocean surface, both the pressure change and the winds. That drives the sea surface up further. Then you have wave setup, which is the amount of extra rise in the sea level, which happens due to a big wave coming along. Then that wave hits the beach, it runs up, and that run up is called swash, and it may get into your house even. And what happens? In addition, in this area, you have a special problem, which is large measure not taken into account in a lot of the future calculations that are being done. And that's that the whole area in southern Louisiana, at least, is sinking. It's sinking, that process called subsidence. It can happen due to extraction of oil, extraction of natural gas, extraction of water for drinking water, and some natural compaction of the delta. All of that is going down on in southern Louisiana, and it creates a big problem. Now I'm going to jump ahead and show you some projections from the rest of the world. Then I'll come back and get to the rest of the impacts into Louisiana. And we can actually do calculations which tell us what the effect of this rise in sea level is, even if the nature of storms themselves doesn't change, just due to the rise in sea level on a benchmark event, a benchmark flooding event. And I'll pick the once in a century high water because that's the benchmark that FEMA uses in that, for instance, the National Flood Insurance Program, and is sort of a globally used benchmark. And this is what I want to think about. In the future, due to sea level rise, how much more often will the current once in a century event, sometimes called the 100-year flood, occur? And what we find is kind of troubling. These panels reflect mid-century around 2050. These reflect end of century around 2100. This is in a high emission scenario. This is medium emissions. This is low emissions. If you look, you'll see as you move by 2050 from a low emission scenario to a high emission scenario. It's a little subtle. You have to look closely, but there actually is very little change in what to expect, and I'll explain that to you in a minute. And that's actually because sea level that we're going to get in the future for the next 30 years or so is actually what we're going to get is baked in. And that's due to the fact that, one, there's a lot of inertia in sea level because you have to raise a lot of ocean water, and the heat takes a long time the ocean takes a long time to respond to the heat that's gradually moving into it. And secondly, that it's, no matter what emission scenario you use, we've had a big buildup of emissions already in the atmosphere, which are warming the ocean. Those two things mean you don't actually get much change in what I'm going to call the multiplication factor, or sometimes called the amplification factor of the 100-year flood. And don't try to look at every dot, but what happens here is that at many places around the world, if you look at this scale here, this is the amplification factor, that the current 100-year flood becomes a yearly event by 2050, including many places in the United States, Jacksonville, Miami, San Diego, Los Angeles, Honolulu, and on and on. And by 2100, other places, for instance, New York, Boston, San Francisco, Charleston, South Carolina, see their once in a century flood become a once every year event or more frequent. So we're in a situation where essentially, no matter what we do with emissions, by 2050, we are going, at many places, we are going to see that once in 100 event, which happens once a century, occur at least annually, pervasively in a lot of places around the globe, and then at most coastal locations around the globe by 2050. The situation is a little different here for southern Louisiana. I'll explain it to you a little later in the talk. Now let's look at some of the other impacts we have. We actually are going to get more extreme precipitation. Basically, the way to think about it is when it rains, it's going to pour. And the reason for that is there's a lot more moisture evaporating from the ocean surface. Moisture from the ocean surface gets entrained in rainstorms under conditions when it's going to rain. So there's a tendency for heavy rain events to become even heavier. These are rain events that deliver, instead of a few tenths of an inch or an inch of rain, 2, 3, 4 inches of rain or more in a day. We have seen an increase in number of very hot days. Extreme heat, particularly in sequential days, is the major cause in the United States of climate-related mortality. And here I have the death rate. You're getting all too used to looking at charts like this, unfortunately, for daily mortality in a famous heat wave in Europe, which killed somewhere between 40 and 70,000 people in 2003. The extra heat in that heat wave was attributed to the buildup of greenhouse gases. It was a very rare event that was still rare, but made more likely by that buildup of greenhouse gases. And to one way to think about the number of people that died, here's the spike in deaths due to the heat wave at the end of August. It was a flu epidemic, a pretty good one, in February in the same region. This is Central Europe. And you'll notice the total number of deaths under this curve is actually not much different than the total number of deaths under this one. So deaths in a heat episode can cause a lot of problems and can hit a lot of people, particularly in areas that don't have air conditioning. There are going to be large effects on natural ecosystems, like the widespread death of coral reefs that's occurring gradually now across the tropics, unfortunately. We've become all too familiar with the fact that some areas get not wetter, but drier, and I'll explain later why both can happen at once. Parts of the United States and the world are seeing increased frequency of drought. Here's a famous picture from Australia. You see the kangaroo there. It's an incredible photo. If it weren't so frightening, it would be beautiful, I suppose. The increase in drought in certain areas is just creating the fuel for forest fires. You've heard enough about them recently in the news, including the one that's going on near Boulder today that I don't want to go into in detail. And then remember that sometimes these events bring more than one threat at a time. So this is what happened in Hurricane Harvey, where certain areas in Southeast Texas near Houston got 50% more rainfall in a short period than they ever had before. So they had both the damage along the coast and the flooding from the intense rainfall. And all the things I've just showed you, going from the sea level rise to the extra heat to the sea level rise, to these effects in terms of flooding, drought, and ecosystems, are all changes that have been attributed for one or more of their events that have occurred in recent years to the buildup of greenhouse gases. So that's to remind you, this is not hypothetical. These impacts are not something I'm making analogies for what will happen in the future. These are things that have already begun to occur in much greater numbers than in the past. Now let's project and see what's going to happen in the future. Think about two futures, low emissions and high emissions. Low emissions world is one that would be more or less consistent with what the strictures under the Paris Agreement are, which are keep warming in the 1.5 to 2 degrees or 3 to 4 degree 1.5 2 degrees Celsius or 3 to 4 degree Fahrenheit range. This gives us an average global temperature of 1 to 2 degrees in this map, and you can see it's a modest warming. The stippling just means that it's highly statistically significant and that the models are in pretty good agreement. There's that extra warming at the high latitudes I talked about before, but this is what's expected at the end of the century. It's a different world than today, but a modestly different world. Here you're talking about a whacked world. This is just totally different. This is a 3.5 to 5.5 degree warming world. It's in Celsius, up to 10 degrees Fahrenheit warmer perhaps. We're seeing warmings at the high latitudes that'll remake the Arctic and some of the other high latitude regions, like parts of Alaska. We're talking about warmings up to 10 degrees Celsius, phenomenal. That's 17, 18 degrees Fahrenheit. We're talking about remaking the world, and frankly, we don't know in great detail what that world would look like. Same thing for precipitation. There's a modest change. Here, there's less agreement among the models. That's why there's a lot of cross-hatching. The blue means wetter. That's where that wetter atmosphere due to evaporation from a warmer ocean is the dominant effect. The brown or yellow are areas where the dominant effect is drying due to the fact that the extra heat dries out soils. That's why you can get the two together. Some areas are dominated by extra evaporation from the ocean. Some areas are dominated by extra drying that occurs primarily due to drying out of certain of the continental areas, but also has an influence over parts of the ocean. And the net effect is you can see both extra precipitation and extra drought in areas like Central America, southwestern United States, the Mediterranean basin, Australia, and Southern Africa. So keep that in mind. The two things you don't expect to see together actually can happen together in the world as it's developing. I want to go back to sea level rise for a second. these are the this is I put this in here because it's an important lesson in terms of how policymakers might want to think about these changes. This is the change in the projected warming out, not to 2100 as scientists often projected, but out to the year 2300. So you have a lot going on here, and this is the expanded scale of 2100. And here's the point I tried to make before. Excuse me. Until you get about 20 up, this is the high, but the red is the high emissions, the blue is the low emissions. This is the 1 to 2 degree world. This is the 4 or 5 degree world. When you get up around, until you get into 2050, the effect of the different emissions is historically is very small. That means, and this is sea level rise, remember, that we know more or less what the sea level rise is going to be by 2050, even though there's a lot of uncertainty in the later part of the century. And by the way, this uncertainty has two sources: one, which emissions curve you're on, and number two, the uncertainty created because we're not quite sure what the sensitivity of the climate is. That is exactly how it relates to the buildup of the greenhouse gases with high precision, and different models project different outcomes. So you always have to think about those two uncertainties. But if policymakers shouldn't be daunted by the fact that there's a lot of uncertainty up to in the latter part of the century and certainly beyond, they should realize that there's a pretty good understanding of what's going to happen by 2050, and that's probably where they should keep their eye on that, while at the same time making plans for 2100 and in the second part of the century, but also knowing there's a lot of uncertainty, and they should be making plans to which we can make judgments and adapt as new scientific information comes in, and maybe change those plans. So if you build a big, hard concrete coastal defense today, you maybe should think about building it in a way that's adjustable as we learn more in the future. The other thing you should see from these curves is if you go way out, and if you're worried about losses beyond the end of the century, the problem just continues and continues to accelerate in the high emissions curve. In the low emissions curve, sea level eventually starts to stabilize. So although we don't see stabilization in this century in the low emissions curve, we do see much less sea level rise than in the high curve. Very quickly on some other impacts. The Arctic, we've all heard these stories about the Arctic ice cap, floating ice disappearing. This is a projection under the low emission scenario. It's ice, which is reflective, tends to keep Earth a little cooler. This is a projection under the high emission scenario. It's blue, it's ocean. It absorbs instead of reflecting sunlight. That leads to what's called a positive feedback, where a little additional warming leads to yet more warming, something we'd certainly like to avoid. This is ocean acidity. A lot of the critters at the base of the ocean food chain are shell-forming critters. Shells dissolve when you get extra acidity. We don't know everything we need to know about how this is going to play out. We do know that in low emissions scenarios, we keep the change in acidity a 1/10 or 2/10 of the pH unit. But when you get to high emissions, you're talking about 6/10 of a pH unit, which is like a quadrupling of the acidity of the ocean at that point. Other future impacts look a lot like the impacts we've already seen, increase in, and I'll put a caveat on that, unless we go over a tipping point that we're uncertain about, and I'll talk about one of those in the future. Extreme heat intensifying, crop yields in many areas decreasing because many crops, like corn, for instance, are very sensitive to, and soy, they're very sensitive to heat, especially when you get up around 28, 29 degrees Celsius during the growing season. Precipitation intensifies for reasons I've explained. The dry season gets longer and drier with more drought and more wildfire in certain areas. I've explained why that's going to happen in some places. Ecosystems, more declines. It won't just be the coral reefs. There's going to be a lot more damage to ecosystems. And for your part of the world, hurricanes getting stronger, wetter, and there are some indications they'll get more persistent upon landfall, which is how all those high levels of precipitation has occurred in Hurricane Harvey occur. Now, for one of those tipping points, one thing we're worried about with those sea level rise projections is that they may be an underestimate. Not only do we have the problem of the sensitivity of the climate to the buildup of greenhouse gases, which is a certain uncertainty in it. Not only are we uncertain about the emissions trajectory for the future, But it's possible that these ice sheets, for which we have great difficulty modeling what the future is going to bring right now, can actually bring quite a much larger contribution to sea level, particularly beyond the 21st century, the one we're in. For instance, Greenland has the ability to release 23 feet worth, 7 meters worth of sea level rise. But its disintegration is believed that it's going to happen gradually as it melts away over the course of probably a full millennium. So this is going to be a slow process, making a significant contribution to sea level rise as we go. But most of that 23 feet will still be sitting as ice on Greenland for several centuries, many centuries to come. Antarctica is a different story. It's the ice sheet there is apparently unstable in certain regions. I'll point out a couple of them here. Over a long period of time, more of it may become unstable. And we believe that about 20 feet of sea level rise equivalent could become in play, not a millennium from now, but gradually, beginning now, over the course of a few hundred years. That would imply a rate of sea level rise which is much higher than anything that society has had to deal with, except in certain unfortunate locations, as you've had to deal with in southern Louisiana. And this brings me back to why the 1.5 or 2 degree target. Just very quickly, these are 5 ways to break down the risks from climate change, what are called large-scale singular events, like passing a threshold that would cause destabilization of parts of the Antarctic ice sheet. The aggregate costs is this bar. The third bar is the distribution of impacts. That is, you don't want to get into a world where certain people, which we're already in, are suffering a lot, and other areas are getting away scot-free. Those lead to political tensions, which could have reverberations down the line. Extreme weather events, the damage due to hurricanes, for instance, and the damage to unique and threatened systems like coral reefs, like the Arctic, like certain niche ecosystems, which are important for certain people in certain places. And we see that red, which is the high risk color, by the way, this is the bar which tells you degrees above pre-industrial level. When you get around 1.5 degrees above pre-industrial level, these start to kick in, so that when you get into 2 degrees, you're starting to approach the high risk range on every risk, or you're already well above it. That's where the 1.5 or 2 degree target comes from. Now, in the time I have remaining, which I reckon is about 10 minutes or so, we're going to talk about how these impacts play out in your neck of the woods. And we're going to talk about sea level rise, extreme heat, heavy precipitation, drought, and hurricanes. This, as I told you at the beginning, sea level rise is going to be a little different down here in terms of the effect it has on storms. Your 100-year storm isn't going to become a 100-year flood isn't going to become a once per year flood like in a lot of other places. When you get to 2050, it's going to be the frequency at which that storm returns, instead of being once a century, might come down to once every 50 or 60 years, and then gradually increase in frequency thereafter. The floods that you're going to have trouble with are the lower but more frequent floods already, the 10-year flood. It has a height down in, say, Grand Isle of about 1 meter, and the multiplication factor for that one is a factor of nearly 30. That is, by 2050, you'll be having, Grand Isle will be having that what's historically a once in every 10-year flood about 30 times as often, which means 3 times a year. And by 2100, that flood will occur 1,860 times as often, which is 176 times a year, which means it's happening on every other high tide. It doesn't have to wait for a storm. And the closest station I can have, which gave a good figure I could show you, is Fort Pulaski, Georgia, which here's the historical flooding, tidal flooding in Fort Pulaski. It used to be nil, basically, at 50, 60 years ago. By now, it's built up gradually due to sea level rise. So they're getting about 40, 45 days a year with flooding on the high tide. And then you project for different emissions futures, you project more and more frequency of this kind of flooding, so that when you get out, to around mid-century, their problem is flooding is going to occur on every high tide, every higher high tide, as they say, the higher high tide of the day, every day of the year. Think about that. Extreme heat, you're in an area of the south, here's the southeast from the National Climate Assessment. You're in an area which actually is cooled a little bit for reasons which are not well understood, but the projections are that that cooling will, which is a natural signal probably, will probably diminish as we go on. And in addition, this is the maximum temperature. This is the trend in days above 95 degrees. You can see that's not the only measure there is of heat. I could have used 90 degrees and the picture would look different. You can see it's nighttime temperatures, however, have increased. Days above 75 have increased. That's why you've got a bunch of red dots here. Nighttime temperatures are interesting and important because that is the temperature which the human body is most sensitive to in terms of needing a period to recover. And for people without air conditioning, when the temperature gets above 75, approaches 80 Fahrenheit, that's when the body gets into trouble. And you can see here in terms of number of warm nights in the future, in the low emissions case, even in the low emissions case, you get a substantial increase in southern Louisiana. In the high emissions case, you get half the year where the night never gets below 75 degrees Fahrenheit. It gets worse if you think the temperature, you remember temperature isn't the best indication of the physical problems that are going to happen to the human body. There's something called the wet bulb temperature, which combines the effect of heat and humidity. And actually at high enough wet bulb temperatures, which can occur when the outside temperature is in, say, the upper 80s or lower 90s, but the humidity is high enough, it becomes dangerous to go outside. In what's called category 1, the temperature approaches on a continuous basis what it was in the 1995 heat wave, where 1,000 people succumbed, 1995 Midwest heat wave. But there's category 4, which is even worse, which is an indication that heat stroke is likely even for fit individuals who do moderate exercise. What that means is no construction outdoors during those days, no farm labor, no kids playing baseball. It's a much different world. And you can see, while that's a world we sort of edge into at the end of this century, where here we have 1 week worth of category 3, which is bad enough in this area, and a day only of category 4, which is the deadliest in these projections. But when you get starting early in the 21st century, then going toward a 22nd century, going to the end of the century, it's like the whole Eastern United States comes into significant number of days, a whole month in many of these areas of category 4. If you keep the emissions in the low scenario, you don't get anywhere near that risk. Heavy precipitation, it's been increasing in this area through the 40s and 50s. It's increased by about from about the 40s and 50s. It's increased by about 30 or 40%. These are the individual dots. There's been an increase in intense precipitation, some of which you remember well, like that August 2016 event, which caused a lot of havoc in Louisiana. That trend is likely to continue, and it's likely to accelerate into the future. Drought, I have explained why. Drought can occur at the same time, if not in exactly the same place at the same time as heavy precipitation, but you can get areas which are flooded by this extra precipitation during the rainy season, but actually get periods of drought otherwise. And that, again, that effect is due to the feeding of moisture off the warmer ocean surfaces, combined with drying from certain areas because of essentially the soil being baked by the extra heat. Hurricane projections, the projections are more category 4 and 5 hurricanes in the whole, what's called the North Atlantic Basin. A shift from category 1 and 2 doesn't mean more overall hurricanes. It does mean more damaging hurricanes. The effects could be ameliorated in some places because the storm paths, for instance, in the Northeast, are projected to push the storm landfalls off the coast. But in the Gulf, it's not clear that that's going to make any difference. I haven't seen any calculations, but storms that generate down here tend to wind up having to hit land one way or the other. There's growing evidence that the storms that you're encountering in the Gulf slow down as they reach the coast, stand still, as I mentioned before, and you get that extra rainfall. And then also, as they approach the coast, there's been a certain trend, not definitive yet, of extra spin up that wasn't seem to be happening before, so that you get less warning that an intense hurricane is coming, because it'll go from a category 1 or 2 to a 4 or 5 very, very quickly. Bottom line, higher risk due to hurricanes. I want to make a few comments before I end on the question of adaptation. There are 4 different ways. You doubtless are familiar with all of these because of what's being done to protect southern Louisiana, what has been done historically. There's hard protection, pouring a lot of concrete, surge barriers and seawalls and levees, ecosystem-based protection, which basically leverages off the effect of coral reefs or mangroves or wetlands, and enhancement of those and protection of those can provide some protection for the future. We know hard protection works. We also know it's expensive, and it's not going to be possible to afford doing that every inch of the US coastline. And so you're going to be competing in the future with other areas that are going to be fighting for a limited number of dollars to be able to protect their areas. We know ecosystem-based protection is cheaper, but we don't know how effective it is yet. Then there are less expensive ways, accommodation, like raising houses. If sea level is in the low emission scenario, that might work well enough in most areas. Might not work down here in some areas, of course, but it runs out of its protective, the ability to protect once you get too much sea level rise. And by the way, another example of accommodation is having good early warning systems, something that has improved but needs to be done even better down here, and emergency response, not just down here, but where I come from too. There's advanced building land out. This has been done traditionally. It's why the Netherlands are the size it is. There's been proposals recently to do it, to build out Manhattan. The expense of it is very large. Local policymakers tend to like it because it's a source of new revenue from development. There are a lot of reasons not to do it. It's a killer for ecosystems. It's also very expensive. And then there's relocation, which is less favorably called retreat or managed withdrawal. Unfortunately, because we are not going to be able to afford to protect everything, there's going to be a lot of relocation. I think down here, there's going to be a substantial amount. In the high emission scenarios, there's going to be a lot where I come from. So we have to keep the eye on this. You don't want to get in a situation where populations need to be told that they're going to have to leave. Basically, you want to give people choices. You want to relate this to problems like buyouts, but ultimately, if we ignore it, it'll be something that's done on an emergency basis, and that's the worst possible outcome. So there are the hard realities. There are plenty of things we can do to adapt along the coast, but we should always keep in mind there's an equity issue here. People who have the highest exposure to coastal risk and the highest vulnerability are often the ones with the fewest resources and the least capacity to deal with the problem. They won't be able to respond. Others will have the ability to respond. They will have the resources. This is a situation which is rife for the potential for making high inequity already much worse in the future. And that's a political problem that needs to be addressed. And as I said, I think relocation will become a dominant mode of addressing the problem. What can we do to reduce the risk? Number one is always reduce the greenhouse gas emissions through regulation, incentives, and pricing mechanisms like putting a price on carbon. But this isn't going to be enough. There is no description of a high emissions world that I've seen that says that people can live in it successfully. A low emissions, even in a low emissions world, we're going to have to do a lot of adaptation as we are doing today, and not as effectively as we should be doing it. We have a lot to learn. But so no amount of emissions reduction is going to take us away from the need to do a lot of adaptation, some of it requiring a long lead time, and we're going to have to be doing it indefinitely because, as I said at the top, and as Michael Mann says, there is no new normal. It ain't going to happen for a long time. And one of the things we're going to need to consider is actually sucking carbon dioxide out of the atmosphere. This is my last slide. You can see here, this is from an adaptation of the slide from the Center for American Progress, that this breaks up the US economy into where would the emissions reduction come from that would get us to zero net emissions by 2050, which is a plausible goal in terms of meeting the Paris target. And you see that a substantial chunk of it either has to come from, to be decided, not very encouraging, or has to come from carbon removal, finding ways to get the carbon that's already been emitted out of the atmosphere. I just point to it because you have a big oil and gas industry here, which not only are likely to become the subject of further regulation due to this problem, but where there's the potential to actually store some of the removed carbon somewhere in some of those deep wells, and the industry already has experience with doing so for other purposes. So thank you. I know I was a little fast, but there's a lot to cover. I'll welcome questions later.
Thank you so much, Dr. Oppenheimer. Depressing, but I feel like we are armed and ready. You painted such a vivid picture of what's happening with our climate. And this is a planning conference, and it's so critical because city and community planning plays such an important role in how we can address the climate change issue. Through the built environment, we can both mitigate and adapt. And as we discussed, Louisiana's Governor John Bel Edwards has set a goal to reach net zero carbon emissions by 2050. And from your slides, it's very obvious that this is a goal we must meet, which will require all hands on deck to reach this critical benchmark. And I hope during our discussion, we can talk about the actions, policies, and changes that will be needed to achieve this goal. And so with that, to figure out these solutions and strategies, I'm going to invite our panelists today. We're going to have Colette Pichon-Battle, Dr. Sam Bentley, Dr. Kenny Cole, and Liz Russell join us. And I'm going to ask each of them to just briefly give an introduction of themselves and the work that they do. And Colette, we can start with you.
Bonjour, y'all. Thank you so much, Camille, and thank you, Dr. Oppenheimer. What an amazing presentation. My name is Colette Pichon-Battle. I'm the Executive Director of the Gulf Coast Center for Law and Policy. I am located here in St. Tammany Parish, Louisiana, where I am a native of. And my family has been in the Bayou Liberty area since before this was America. So I'm really proud to be here as a proud Louisianian coming in on this conversation. The work we do really started in the aftermath of Hurricane Katrina, and we currently work with communities of color on the front line of climate change. We prioritize African American and Native American communities to really get in on this climate justice fight. It's an honor to be here today. Thank you.
Thank you so much, Colette, for being here with us. Sam?
Hi, everyone. It's a great pleasure to be here. My name is Sam Bentley. I'm a professor of geology at LSU in the field of coastal geology and sedimentology. So I've been working with the state's Coastal Master Plan and CPRA for much of the last decade, and I'm very excited to be part of this dialogue. I'm also Vice President for Research and Economic Development at LSU, which of course means that everything I say today is my own personal opinion and not any part of LSU's policy. So there we go.
Thank you, Sam. Kenny?
Hi, I'm Kenny Cole. I'm a physician by training. I was both an internist and infectious disease specialist. Did primary care for many years. Now I work as one of the system executives at Oxford Health, basically in a role that revolves around redesigning how care is delivered, primary care transformation, care model design and redesign, things like that.
Thank you so much, Dr. Cole. Liz?
Thanks, Camille. Thanks for having me, and glad to see so many Louisianans and other allies on the call. I'm Liz Williams-Russell. I'm the Climate Justice Program Director at Foundation for Louisiana, though my background is actually in architecture and coastal planning. Foundation for Louisiana was originally founded as Louisiana Disaster Recovery Foundation in the days following Hurricane Katrina. really meant to be an institution that could get resources out on the ground to communities that were left out of the traditional philanthropic response or our institutional responses to disaster. So we're really born of a very explicit understanding that Black communities, Indigenous communities, low-income communities of color are more likely to live and work near toxic facilities and petrochemical companies emitting pollutants, reside in areas where there's more flooding, receive inadequate infrastructural investment to mitigate risks and to prevent disasters, and experience delayed and insufficient responses in recovery investments immediately after disaster. So we work to build people power and strengthen civic infrastructure. We work to advance just climate policies, analysis, recommendations, advocacy, and to cultivate new narratives that actually support statewide climate action. So I'm really grateful to be here, Camille. Happy to exist with y'all in the tension between the world as it is and the world as it could be. And really excited to build together a more healthy, just, and vibrant Louisiana.
Great, thank you so much, Liz. Thank you to all of the panelists for being with us today. We're going to get into our discussion and we're going to incorporate questions from the audience as we talk. So attendees, please submit all questions into the Q&A using the button at the bottom of your screen. But first, I'd like to go to each panelist. That was a lot for us to hear, especially many of us are from coastal communities. These are the places that we're from, that we love, and that we're taking care of, and that we're mission driven to improve. And we just unpacked. Dr. Oppenheimer did such a great job of unpacking a lot of not just scientific detail, but images about our future and what that means. And so I would love if each panelist would share one reflection you had as you listened to Dr. Oppenheimer. What does climate change mean for you in your line of work? And so with that, Liz, I'll start with you.
Thanks, Camille. One thing that strikes me is just how personal all of this is, right? I'm from New Orleans originally. My family is all over South Louisiana. And though it's easy to begin swimming in all the data sets, I'm always pulled back to the reality that these changes in our climate may feel abstract, but these seemingly distant futures really affect everything we care about: our communities, our culture, our economy and jobs, our environment, housing, transportation access, healthcare access, on and on and on. And so it strikes me, that as sort of dire and transformational as the future data is that's presented, we're also really already experiencing impacts of climate change here in Louisiana. They're not a future scenario here. Katrina, Rita, Gustav, Ike, Isaac, the floods of 2016, Laura and Delta this year, all of those have impacts across the spectrum of things that we care about. And so it's not a future scenario. Every single parish in the state of Louisiana has been under at least one, if not many, federal flood declarations in the last 15 years. So how do we acknowledge not only those environmental changes, but also all of the ways that those impact where people with resources are picking up and moving, what that means for areas losing population, gaining population, on and on. How do we actually bring that understanding into actionable steps that we need to take, in the short, medium, and long term to really take care of all of the things we do care about?
Thank you so much, Liz. And we'll pivot to Dr. Cole as a medical doctor, infectious disease specialist. We're still knee deep in the COVID-19 pandemic. When you hear about what our future looks like, what does it make you think of?
Well, it makes me reflect on the parallels between sort of what's happening in healthcare and the climate overall, because, health right now, we spend 20% of our GDP, in healthcare as a country here in the United States, and yet, I think we rank, in the 57th in life expectancy, and what we see part of the reason for that is because of the drastic healthcare disparities that exist, across the United States, and we saw that, in the purest sense, from this COVID pandemic, and that the population that has been ravaged, by COVID have been individuals typically of lower socioeconomic status and where healthcare disparities and inequities are so prevalent. And there was actually the lead article of the New England Journal of Medicine was from just a few months ago was basically came from the data in New Orleans, reflecting on those disparities. And part of that is because we have this, sort of approach in healthcare that we pay for things after the damage is done, right? So we'll pay, we pay for the bypass surgery, we pay for the stent to go in the blocked coronary artery, and yet we don't pay for team-based care with collaboration of integrated behavioral health and nutritional support, where a care team is coordinating, collaborating, working very closely together to manage, a patient in such a way that those outcomes, never happen. And so it's really a failure of upstream investment, and instead the money is spent on downstream solutions. And it seems like, Dr. Oppenheimer certainly alluded to that in his talk, in terms of either we kind of pay now to try to prevent or pay later in a much bigger and more expensive way.
Thank you. Dr. Bentley?
So that was a very thought-provoking talk. Thank you, Dr. Oppenheimer. It brought home to me that climate change impacts, just like politics, are very, very local. And we need to understand what recent changes really are, and we need to support the best science to understand what future scenarios may hold. So we need to focus very much on that and understand what those impacts are going to be on our region. So just as an example, I mean, when during your talk, you mentioned nuisance flooding. Well, a colleague of mine at Louisiana University's Marine Consortium, Alex Kolker, did a study recently where he found that in the last 20 years, the frequency of nuisance flooding is increased by a factor of 5 to our coastal marine laboratory. That means that, sort of the highway has the potential to go underwater, or at least driveways, going from less than 10 times per year to 50 to 75 times per year. That's in fair weather conditions for the most part. So it's a great example of what Liz just said, that it's already happening. And it really is. So that's what I was thinking about.
Thank you. Colette?
Yeah, really, really appreciated the presentation. And of course, the work that I do is specifically with communities on the front line of climate change. And so the science is always intriguing to me, and it's something that I strive to learn and understand. But what stood out for me were 3 points in the presentation where there was a mention about a distribution of impacts, a mention about this being an equity issue, and really talking about the folks who have the highest exposure, have the least amount of resources to deal with it, and then really thinking about those adaptation options. And if you play all of this out and take it out of the political theory or the social theory, and you play it out, as Liz was saying, in real terms, in real time, you start to look at the politics of climate change and how they're impacting folks, right? So what does it mean to have millions of dollars put into social media and mainstream media to get people to even just question climate change? That'll pause us 20 years of just getting people ready for it. And what does it mean to actually acknowledge that those with high exposure have the least resources? That's a good start, but there's another piece to this conversation, which is globally, the people who will experience the worst impacts are the people least responsible for putting the emissions into the atmosphere in the first place. We're not just talking about sort of in this, like a hurricane hits everybody evenly and everybody has to deal with it. We're not talking about that. We're talking about an emissions problem that is causing global imbalance and is being caused by a particular privileged class of people and making the entire globe pay for that privilege. This gets to those politics. This gets to that unfairness. This gets to the conversations that most folks don't want to have. Who are those folks without the resources? And what is the root cause of the disparities in the first place? And how much of this system do we have to change? Do we just need to capture carbon and store it in an underground well? Or do we need to rethink our entire social structure? So I really appreciated both the acknowledgement of the science and the impact on people, because it's this part we've got to move through in order to save not just Louisiana, but so many communities that are facing the impacts today.
Thank you so much, Colette. You know, I talk to people all the time around the adaptation measures and the policy needs, and I often hear that, you know, that individuals don't necessarily know what to do, but more so that we live in these political cycles where decisions are made in increments of time that have nothing to do with the science and with nature. And so I'd like to build off of your discussion and turn to Dr. Oppenheimer and then open up for a conversation about what is it that we need to do in the next 3 to 4 years and in the next 10 years. And Dr. Oppenheimer, is it realistic to think that we're going to be at the low emissions and have that trajectory? Because it doesn't seem as the world is doing enough to reduce emissions. Michael's frozen. Sam, do you want to jump in?
Well,
Can you
go ahead.
Now I can hear you.
hear me now?
Yes, sir.
Okay. So I have to say, to be brutally frank about it, I and most of my colleagues think the idea of keeping 1.5 degrees off. And the reason for that is, although this problem was first identified as a problem over 125 years ago, and although government started talking about it about 3 years ago, they haven't gotten serious enough about it. And in cases where they have gotten serious, there's always other stuff that comes in the way. That's the way life is. You know, if our government was serious about climate change now, still the COVID pandemic would interfere with their ability to get things done on the climate side, probably. Political fragmentation of various kinds. No country can be a leader forever, because that's the way politics works. But what one hopes is that enough countries that have the ability to do something about it, because they're emitting too much, get engaged, so that when one country is distracted, another country can act in a leadership capacity. Whether that would have been possible right this last year, I don't know. Bringing it down to the US, we see the same effect. You know, one administration, the Obama administration, started down a good path. The Trump administration just pulled back everything the Obama administration did. We can't do that too many times and expect to get anywhere near 1.5 or 2 degrees warming. And to bring it down even further to the more local level, you know, but you also have a lot of renewable energy potential. If you can somehow square the circle down here and figure out a way to make the transition gradually enough so that it's done in a way that people aren't hurt, that it's done fairly and equitably, and that it actually gets the job done, then you'll have created a lesson for everybody else. So the reality is it's different in every place. There are certain things we know we have to do, like provide the incentives to incentivize renewable energy, disincentivize fossil fuel combustion. But you know, how that plays out, each different constituency, each different government is going to have to determine for themselves. But unfortunately, this is also a problem. We have to act together, because if half of us act and half of us don't, the place is still going to be a mess.
And you know, thinking about a future economy, I want to kick it over to Colette, who, you know, I know this is something very meaningful to you.
Yeah, I mean, you know, I didn't understand in the aftermath of Katrina, or even the aftermath of BP, or all of these storms and crises, I didn't understand that really the economic system is a big, crucial cornerstone of this conversation around environment and people and survival and disaster preparation and recovery. What has to happen is a complete rethinking, reimagining, re-innovating of our economic system. And this will challenge folks because for a very large swath of people in this country, the economic system is pretty okay. You can turn on your lights, you can go in your house, you can send your kids to school. Maybe you have to struggle a little bit to pay the bills, but it's pretty okay. But if you look at the racial wealth divide, you'll understand that the economic system of this country is particularly biased away from people of color, specifically Latino and Black folks, and moves in favor to boost and support folks who are white. And so we have in our economic system a racial disparity that is rooted in a structural maintenance and the maintenance of structural systems that are discriminatory. In addition to just looking at the social outcomes of these economic disparities, you have to now also look at the drivers of our economy. Our economy is based on an economic philosophy of extraction. And this economic philosophy of extraction resists all notions around repair, restoration, and even fairness and justice. And so we have an economic system that refuses ideas of justice, refuses ideas of equity. And so we have to change that system. I think my final point is that we need our economic system to shift from monopolies and just a few people owning things that were never theirs to own in the first place. I mean, for crying out loud, who gave permission for anybody to own the oil and gas that's down here? Why isn't it the whole state of Louisiana that owns those natural resources? Why don't community own these natural resources in commons, as opposed to just a few companies getting financial and profit benefit from this? We're in a situation now where we have to rethink who controls the things that we need to survive, and why is it so hard for us to access it? Not just our electricity, but our water, our land, the rain. Watch these laws that are coming across the board to stop people from having solar panels, to stop people from controlling the sunshine. I mean, this is another level of extraction. This is a level of monopolization that we have to resist. And while we're fighting, we have to innovate a whole new system because this climate reality is already here.
And Liz, I know that you're wanting to follow up on that because we've got to provide work to people in this new economy.
Yeah, absolutely. Thanks, first of all, Colette, for your leadership and for speaking truthfully and transparently about the way that our system works. You know, for me, I mentioned existing in the tension between the world as it is and the world as it could be, and the need to build a different kind of economic system that allows for representative access and actually centering those communities that have experienced decades and generations and centuries of divestment and underinvestment to sort of keep them out of the economic opportunity that exists. I want to just touch on, for me, one of the most critical things as we work to diversify our economy and take steps towards creating a just transition. One of the things that's most pivotal for me is just the tremendous amount of revenue that already exists in the state of Louisiana that is not currently being leveraged to the extent that it could be to create inclusive wealth and inclusive economic opportunity. Just the resources coming down for the Coastal Master Plan, the resources for the Louisiana Watershed Initiative, you know, the Office of Community Development, CPRA, the DOTD, you know, where there are huge investments being made in infrastructure. How do we support a comprehensive strategy towards inclusive economic opportunity? What are the procurement practices in the state of Louisiana that prioritize Louisiana businesses and disadvantaged business enterprises as part of those procurement strategies? We know that people are more likely to hire people who look like them. So how do we actually center businesses that create representative access to these economic opportunities that are good paying jobs with, frankly, transferable skills from the tumultuous and commodity based oil and gas industry that we at least perceive ourselves to be reliant on? How do we actually support small businesses that are Louisiana based as well as a workforce, even as we create a new and different type of economy that is more shared? You know, for me, this is an opportunity to leverage. It's an opportunity to diversify. It's an opportunity to frankly learn lessons that we didn't learn after Katrina, that the money that is invested here should also have multiple benefits. And that's something that needs to be occurring across all of our state agencies, you know, and more broadly, you know, to speak to your bigger question, Camille, of like the 3 to 5 years, the 10 years, you know, I mentioned ongoing population movement, and that has impacts across the board. You know, we see in areas losing land, we see people with resources picking up and moving to areas they perceive as higher and safer grounds. And so in those areas that are losing population, and I want to acknowledge the work of the data center, we're seeing increases in poverty rates, elderly populations as well. We're seeing a decline in ability to maintain social services, invest in infrastructure to reduce risk, really invest in the things that are needed locally, school, healthcare, roads. And then on the reverse of that, we're also seeing other areas grow and grow without any regard for where water should go, any regard for future needs for social services and infrastructure. So for me, when I think about what needs to happen in the next 3 years, 5 years, 10 years, you know, it's about requiring all of our state agencies to not only take steps to reduce the things that cause emissions in their portfolios of work, but also how do they plan for ongoing coastal and climate impacts and actually ensure that their programs, their policy recommendations, their practices internally are really supporting and centering Louisiana people and Louisiana communities and Louisiana-owned small businesses to actually create more just and healthy economy that is capable of adapting to the inevitable change that is already ongoing.
And I'd like to pick up on something that you mentioned. So we don't have the resources. There was the BP oil spill, which provided resources to where we're now at a rate of $1 billion a year building the adaptation measures that are so desperately needed. But those funds run out in a little over 10 years, and we don't have identified resources to cover the adaptation measures needed at the same pace. And so, Dr. Bentley, thinking about the future and restoration and where we're headed, what do we need to do in the next 3 to 5 years, in the next 10 years, to get on a trajectory of having a more viable coastal future?
Well, first of all, we need to decide what we want that future to be. I think it's really critical for us to understand real on the ground what sea level rise and increasing susceptibility to storm surge and nuisance flooding really means for coastal communities over the next 50, 75, 100 years. Do we want New Orleans to be a fragile island surrounded by the Gulf of Mexico? How many coastal communities are likely to be underwater or under a substantially enhanced threat from hurricane flooding? So it's important for us to look at that and decide what we want the legacy for our great-grandchildren to be, and then move towards that. I don't think we can't restore the coastline. I don't think that the master plan really is not striving to do that. Fortunately, it is an adaptive plan. But I think the starting point is for citizens of Louisiana to understand, to look at scientific projections of what worst case, best case, and maybe optimistic sea level rise scenarios might be, and say, how much am I willing to gamble that the small chance of a good outcome might actually work out? And am I more concerned in preserving a portion of the coastline? So I would say that one of the options that we got for medium-term funding is the Gulf of Mexico Energy Securities Act, which does provide us a modest stream from offshore royalties back to Louisiana for coastal restoration. But that's not sufficient. It's enough to keep us, on life support, but it's not sufficient. But I think really determining what we want our legacy to be, and then figuring out from a design and a human adaptation and an engineering perspective, what can we afford to do to get there to the best way we can. And it's a challenge. It's a real challenge.
Dr. Cole, associated with this is a lot of trauma and a lot of depression and abuse and opioid addiction. And we see all the cases increasing as trauma increases across our coast and our coastal community. The mental illness impacts are seen far and wide and felt far and wide in South Louisiana especially. And then when, we're in the midst of COVID-19. It's turned the world upside down. It is, it's the very fast onset of a climate change. It's hit us very hard. What do you think needs to happen in the next 3 to 5 years, in the next 10 years, from a healthcare perspective?
Well, we need to continue to evolve the way we're currently paying for healthcare, and you know, starting to actually pay health systems and providers for how do you keep people healthy and prevent downstream complications, you know, rather than what's been the traditional way of paying for healthcare, which is to pay exorbitantly for imaging, surgeries, procedures, but hardly anything for face-to-face visits, you know, with a physician, and which is one of the reasons why I know people must get very frustrated when they go in to see a primary care physician. They get 15 minutes, if they're lucky, you know, of their time before that provider is on to the next patient. And so rethinking, and it is about innovating and how care is delivered, reimagining, you know, sort of the entire healthcare ecosystem and how healthcare is delivered, with now the financial incentives aligned around how do we actually keep people healthy, keep them out of the hospital, prevent them from needing surgeries. Because the reality is clinical care really only drives about 20% of health outcomes. Socioeconomic factors and health behaviors and mental health determine its drive, you know, 70% of health outcomes. And so more investments into those sectors, less on the pure clinical care.
Does anyone have any other thoughts that they'd like to provide before we go on to the questions? We've got a lot of questions from our viewers, and I'm not even sure where to start, but I'm going to move to the first one that I see. Does that sound good? Some adaptive measures are themselves carbon intensive, concrete seawalls, numerous or large new buildings. Others might actually sequester carbon, reforestation, use of sequestering materials in construction. So how do we build carbon accounting into local, state, and national planning and procurement?
May I step in here? So
yes, please.
We're actually at LSU, and a lot of academic organizations and also NGOs are keenly interested in this. Essentially, we have to develop an economic system of a way of accounting for carbon burial. And there are ways that this is being developed right now. But we have to have something that becomes an industry standard for accounting for carbon sequestered in forests, in wetlands, and also in the subsurface. So it's a matter of a big sort of applied research focus right now, and it's very exciting, and it's within grasp, I think, right now.
It's great. We've got these strategies. We've got to implement them. Thank you.
May I add to that, Camille?
Yes,
because there's a part of this conversation that's very controversial, which is attaching any kind of market-based solutions, especially carbon pricing and tax and accounting. There's necessarily something that happens here, which is while it is a disincentive, there's a trade-off, there's a sacrifice, and oftentimes the communities that are sacrificed are those right next to very large emitting facilities, which are 80% of the time Black and 100% of the time low income. And when folks talk about sequestration, which has to happen, it can happen naturally if we preserve our forests, right? So what's happening now are conversations about how to clear land and build up these monocrop forests that harm the atmosphere even more than if you were to just leave a standing forest. And in the southeast of the United States, including Louisiana, we have some of the most forested areas that can serve as natural sequestration if we preserve them, rather than if we sort of commodify sequestration into something we need to clear, build, and then do probably incorrectly, or at least not as good as Mother Nature. And so while there's a lot to learn here, I think Dr. Bentley's right. There's a lot of interest, a lot of research, a lot of conversation that has to happen. There's also some natural techniques. Traditional ecological knowledge tells us to leave it alone. to leave some of this stuff alone. There are natural ecological systems that can sequester. We don't have to market everything. We don't have to commodify everything. We don't have to control or oppress everything. Some things we can just back off of and admit that we've taken too much.
Thank you, Colette. Michael, did you have something to add?
I had something to add, but it was several steps ago, so let's just let it pass for now. There are a lot of questions. Let's.
Well,
if I could add one more thing to just underscore, and part of what Colette said, for me, part of the preserving and the keeping of the forested land and forested wetland that is still available in Louisiana also comes down to thinking strategically about development and where we allow development to expand, especially with ongoing population movement. And so for me, especially given that we drain everything from the Rockies to Appalachia, means that we need to be preserving land and also thinking purposefully about how to preserve land and also how to reduce our flood risk. And making sure that we're not developing out in ways and taking down those forests in ways that not only add to our emissions, but also reduce the, frankly, storage capacity of those wooded areas for the natural benefits they provide to the ecosystem and to our communities. So I just wanted to kind of latch onto that a little bit.
Yeah, no, thank you. And it gets to another question. Someone asked, what are the best adaptation strategies that local governments can implement? And Michael, I mean, you see the breadth of our problem here, and local governments are struggling because they don't have the resources. Are you familiar with some good examples of local adaptation measures that smaller governments have taken to ward off increased flooding or risk?
Yeah, let me first, I gave up an opportunity to say something on the last question. Let me just answer that first, which is, by protecting natural areas, we will do ourselves a big favor. We need to do that. But that's just going to bring us back to zero, so to speak, by eliminating an unwanted source of these gases. We really have to, unfortunately, look beyond that, because we pile up so much of this crap in the atmosphere. We're just not going to ever have a chance to get to a reasonable climate goal. That I personally don't like technological solutions that just kind of are made up because they'll make up for something bad we're doing somewhere else. But the reality is, this is one of those situations where artificial carbon capture probably has to be used, that we should have been doing forever instead of destroying that capability. So we're going to have to do both. On the adaptation point, look, there are a lot of things that can be done that are low-hanging fruit and are cheap, relatively speaking. And those things should be done first, while we plan for the bigger things that we will probably have to be doing in a lot of places in the future. When Hurricane Sandy was my initiation experience into worrying about adaptation, because I live in Manhattan, and we lost lights for 4 days, no heat, etc. And afterwards, it became clear that a lot of things that you would think were absolutely no-brainers, like not putting the emergency equipment for a hospital in the basement when the hospital is right next to the estuary that's at sea level. This is one of the things that we had been doing for decades. And of course, those things flooded. The hospitals lost electricity because they didn't have either central power or emergency power. So looking around for the obvious things can take you quite far and isn't expensive. And in cases where it is expensive, it's something you should be doing. It should be doing anyway. The trouble in planning and getting communities to take responsibility for the part of the problem that they are responsible for. For instance, one of the big problems is that the whole issue of people hasn't been enforced, and that's a problem for evolving. And that's something that's different in every place. And there are successes in a lot of places. So in the Northeast, we learned a few things after Sandy. We're still, I hate to say it, it usually takes getting kicked at least twice. And you had, you know, New Orleans had Hurricane Betsy and Hurricane Katrina. Unfortunately, the memory isn't that, you know, 50 years is a long time. People don't remember, governments don't remember, the lessons got forgotten. What that means is, my God, do we have to be kicked 2, 3, 4 times in every place? I hope not. But certain lessons were learned, certain places, nobody's perfect, certain places are gradually doing better, and they had to learn from each other. But there's one, I'll say in conclusion, there's one overriding factor that every place suffers from, and that's that most of the finance capabilities at the federal level.
Michael.
Most of the implementation obligation is at the state and local.
Yeah. You were breaking out on me a little bit. The last point was that the resources are at the federal level, but the implementation is at the local level.
Right. And I'm going to try a better modem. I may disappear for a minute.
Okay. Okay. We have a question here. As of late, especially in respect to the past summer, capitalistic support of POC and Black people has been praised through much of our healthcare and resource extraction issues, a result of unchecked capitalistic pursuits. Is there a way for us to build economic systems that are culturally sensitive to Louisiana, supportive of impoverished and poorly supported communities, and maintain sustainability in the midst of present environmental threats? Just making money doesn't seem quite revolutionary enough. Anyone?
I want a shot at the revolution.
Yeah, I do too.
Yeah. Yes, Louisiana person who asked a question about revolution. Yeah, this has been, I've never seen anything quite like this year. And I'm interested in what Dr. Kinney's gonna say, just because I can't imagine being a physician right now, but I'll tell you, as a Black climate leader, it's been really interesting to watch shifts in the system at the corporate level, certainly at the foundation level and the nonprofit level. It's been really interesting to watch people have some acknowledgement and recognition, but also have no idea what the next right step is. And so I'm watching this moment of absolute change at a time when most folks have not effectively taken their own analysis and critique of our current economic system. And if we take a look at it, we might start to question things like labor, not just livable wages and what kind of salary should people get, but like what labor are we counting? What does it look, what is invisible labor? What is emotional labor? How are we understanding a broader definition of labor? And I think this is a great time to explore some of those questions. But what has become clear to me as a native of South Louisiana, someone who's watching these storms, who's watching all of these layoffs in New Orleans due to COVID, who's watching the oil and gas industry and their decline even before COVID. You see lots of folks who, for one reason or another, will never be able to re-enter the mainstream economic system that we have. And so like the questioner poses, there's gotta be something more revolutionary to start to build and address wealth issues. And I think we're talking about land. I think we're talking about access to food production. I think we're talking about access to health, the way the doctor described I think he called it wraparound preventative services. Like, how do you work with a team of people to get yourself healthy enough to withstand a pandemic, or to at least make it less likely that you die from it? I think these are ways we have to redefine wealth, right? We can't just focus on income. We can't just focus on stocks and bonds. We have to focus on people's ability to take care of themselves in a changing climate and a changing reality. I think the first step here is actually indigenous sovereignty. This country still does not acknowledge the sovereignty of nations that were here before we were here. And I'm saying this to you as a Black person. I can't imagine what white folks are thinking, but let's just be clear. There were thousands of nations here. We're on their land. We just took it and now we're exploiting it to the point of creating global imbalance. There's got to be some kind of repair and restoration to that. And it can't be charity. It's got to be justice. And that's going to really start with indigenous sovereignty and land sovereignty. And who gives anybody in this government the right to declare a sovereign nation or reject that request to be seen as such? This is a problem that we have so many nations in Louisiana that are not recognized by the federal government. We traveled to France, to Paris, with the principal chief of the Homa Nation, where they sent a diplomat to greet this nation that had been acknowledged since before this country was started. France and Spain acknowledge the Homa Nation, but the United States doesn't. And what would happen if they did? And what would it mean for the wealth of those indigenous nations on the coast as they face climate change? And what are we talking about when we say economy? Is it making more money for companies? Is it what I call, penalty dollars, which is what we saw after BP? We saw a lot of money come, but it was like a 1% of one fraction of 1% of their PR budget that came to the coast, not real restoration dollars that help us not just bring in wealth, but actually get ourselves stabilized. I think we're talking about something much bigger here. Conversations around labor, conversations around land. How do we center health, housing, and education as part of our cornerstone for really building a society that we want? We've got a long way to go, but the revolution is definitely going to be what we need.
Thank you so much, Colette, for all your leadership. Dr. Cole, do you want to respond to the question? It was around that much of our healthcare and resource extraction issues are a result of unchecked capitalistic pursuits. And, the healthcare inequities have been on high display during COVID-19, especially in Louisiana.
Yeah, it's a complex and nuanced question, but I would say that part of it is to go back and just look at someone like Germany, who has private healthcare. It's a combination of government and private healthcare, just like the United States. But the way health insurance evolved in Germany was actually groups of individuals, guilds of individuals under similar working circumstances kind of got together and said, hey, we can't really predict who's going to get sick versus who's not going to get sick. So why don't we all put our money, into this pool? And then if one of us gets sick, well, then that money that's in that pool can get distributed, to help other people, right? It was born sort of out of solidarity, and concern for one another. The way health insurance actually evolved in the United States was right after the Great Depression. Hospitals were looking for revenue sources and trying to figure out how to get paid. And so they, the Baylor Hospital in Dallas went to the teachers union and said, hey, why don't all of you teachers put money in a pot? And that way, if you get sick, you can come get healthcare from us. And that actually evolved into the first insurance plan, here in the United States. That was Blue Cross. About a decade later, the physicians were kind of like, wow, you're on to something with that. That's pretty good. So they got together and did the same thing, and that became Blue Shield. And so without going into too long of a conversation about it, the way health insurance evolved in the United States was not out of mutual solidarity and how do we keep each other healthy and look out for each other. It actually evolved out of, what's a payment stream, for the providers of healthcare. And, Medicare and Medicaid actually came about because the two groups that became disenfranchised by employer-linked health insurance were the elderly once they left the workforce and healthcare insurance was too expensive, and then the poor who couldn't afford it to begin with. And so I think, here in Louisiana, expanding Medicaid and some of the leadership from the Department of Health and Hospitals around, paying for care differently and, the evolution of community health centers that are going to focus more on correcting those healthcare disparities and inequities and keeping people healthy. I think that's something that's a step in the right direction and not necessarily in those capitalistic pursuits, which has driven, unfortunately, much of healthcare in the United States.
Thank you so much, Kenny. I'd like to shift gears a little bit. We have a couple of questions, and I think Dr. Oppenheimer, we sent you the article in yesterday's paper around carbon sequestration, carbon capture and storage. Elizabeth Maxwell asked, regarding carbon sequestration, do you think the Paul Hawken drawdown work is strong research to follow? Are there other strategies to pull carbon out of the atmosphere that you would recommend implementing or prioritizing?
Well, first of all, and drawing off Colette's comments, number one strategy is stop doing harm. Number two, then having some sensible decision. And this, this goes everywhere, not just, it's a problem everywhere where there's a tree. Some sensible collective decision-making about what happens to this common resource. The third point to realize is that there has been big progress in this regard in some places. There are places in the United States you can point to. China, after devastating its forests, has reforested a lot of areas. There are other countries, parts of India, they've done a good job. On balance, I don't think they're ahead of the game at this point, however. So these are practical things that can be done. Unfortunately, they bring us back to zero. So then the next thing, which relates to Paul Hawken's proposals, are a set of things that can be done, like rehabilitating soils, which can, and perhaps enhancing their natural capability. Frankly, the book is out on a lot of those. We don't know, and I like to be guided by the scientific evidence, and we'll see. Experiments are a good idea in that vein. The thing you have to remember, and the reason why in the end, I fear that we're going to have to go to some technological solution for removing carbon, is that we're caught in a bind. We need, arguably, unless we go to a completely different type of agriculture worldwide, we're going to need more land. We're going to need land because some people are proposing using crops for energy. Sometimes it's a bad idea. Sometimes it might be a good idea. The U.S. experiment with it hasn't been all that successful from an environmental point of view, even though it did shovel some money to people who grow corn. But there's a trade-off there too. The less land, the more land you use for energy crops, the more land that you use for sequestration, just preserving it, the less land there is for people to eat, to grow food on, basically. And how you square that circle of land for preservation, land for energy crops, land for agriculture, there isn't a global, it's not the kind of thing that gets decided globally. And so that's why I'm afraid, no matter what best efforts we make to do these things naturally, we're going to need a sort of a technological solution as part of the picture. None of this is going to work, including sucking carbon out of the atmosphere any way you want to do it, unless we make a transition to renewable energy, period. There is no solution anybody's going to present to you that's plausible, that doesn't have a huge chunk of renewable energy substituting for what we do today.
How long does it take to build the sequestration technologies that we're discussing?
Well, first of all, it takes a long time to get to, we're not at the point where it's commercial. Yeah. So there's going to be, 10, 15, 20 years before we get there. And then the distribution infrastructure for getting the pipes in place to bring the stuff from one place to another, or to build the many 100,000 worth of chemical vacuum cleaners that need to be put in place to get the stuff out of the atmosphere. We're talking 30 years, 40 years. So we're talking something that'll help in the second half of this century. We're not talking the next 30 years. If you want to turn this ship around quickly, which I believe we have to do, what you have to do is take what's available. And what's available now in increasing quantities is solar and wind and efficiency. And you got to use all those. And that's not, I would have given the same answer 40 years ago, except the price of renewables was much too high then. But it's come down, and it's now beating the hell out of fossil fuels at certain places at certain times. Let's take advantage of that.
Yeah, I want to jump in on that because the good doctor mentioned energy efficiency, which we know, especially for Black and Brown communities, is a much easier way to engage, even before we get to wind and solar, which I totally agree with. But we also have to be honest here in Louisiana. We can't just have this philosophical conversation. We have to talk about what this conversation means in a state like Louisiana, where we have our own decision makers stopping the expansion of renewable energy, trying to literally capture a market before they allow the customers to have their own access to the sunshine. I mean, what we should have is not just a shift to renewable energy, but a shift to an energy system that is owned by the community, that is collectively owned, that is locally owned. This is not just shifting from fossil fuels to wind and solar. This is shifting who owns it, how it's transmitted, where it goes, what's the price on it, and bringing it to a more collective process. I still haven't gone vote yet. I'm going later today, and I've got to vote for a PSC commissioner. These conversations are relevant to the things we have to do today. If we don't have people on our public service commission who understand what a doctor who doesn't even live here is saying about what has to happen in order for us to miss the worst parts of this, which is transforming our energy economy into a renewable one, then we should not be voting for them. And this, I'm not even trying to be like political one side or the other. I'm saying, who is acknowledging this problem? And who is demanding that we make this transformation? And that's who we should be voting for, whatever party they're a part of. They need to acknowledge that this is our reality and that this is going to be the only way to transition.
Yeah. Amen to that. Thank you, Colette. We are almost at our time. I want to offer Sam any comments on carbon sequestration before I do a final round of questions for you.
Thanks. This is actually a pet project of mine. I find that right now, if we think of it in terms of coastal restoration projects, if you look around the world's deltas are some of the most heavily threatened locations and densely populated locations by sea level rise and by hurricanes. We're also trying to figure out efficient ways to maintain and even build the land area within those. And I'm pretty sure that the science that we're doing here at LSU and elsewhere will allow us to capture more sediment coming out of these rivers to build wetlands more effectively, and thereby capture wetland carbon. And if we have an economic model that we can use to sort of bank that, not only are we going to be reducing community risk to storm surge, increasing the function of coastal ecosystems, and burying carbon, but we'll be able to get some financial credit for it. And I think that would be a fantastic way to turbocharge our coastal restoration program, and then to market those technologies and approaches worldwide. There, my stump speech. Thanks.
Thank you. Thank you. So I just want to say to everyone, thank you for all of your questions, and I'm sorry that we couldn't get to all of them. I want to do a quick round robin though. I know this discussion can be incredibly overwhelming for people, and so will each of the panelists in 30 seconds tell all of our viewers what's one thing that they can do to be part of the solution. Dr. Oppenheimer?
Well, the most important thing is when you buy anything, you be aware of the energy use that it implies, or the energy that was made in it. There's a lot of labeling all over the place for people to make intelligent consumer choices, whether it's they're buying an appliance or they're buying a motor vehicle, or they're thinking about planting trees. Any of it. Think about when you spend your money, what's the least greenhouse gas producing way of getting roughly the same service?
Thank you. Liz?
Yeah, I would just say find ways to get engaged in your community. So understand the decisions that are and are not occurring in your local and state governments that are impacting the future for you, our families, our neighbors, our communities, and really push to get engaged on those issues. So Together Louisiana, Colette's work with the Gulf Southward Green New Deal, the Power Coalition, even following Louisiana Bra on Instagram. Like, engage your decision makers on the decisions they're making. Even more imminently, look at Amendment 5 on our Louisiana ballot. What are the implications for reducing funding to our local governments and their capacity to subsidize industrial corporations that may not have a sustained interest in the benefits for Louisiana communities. So just really weighing what the decisions are. So finding ways to engage decision makers at all levels of government and know what decisions they're making and inform those decisions and voice your opinions and the needs of your communities.
Great, thank you, Colette.
Yeah, I think one thing we can all do is start telling the truth about climate change. And while it sounds like a simple thing, it's actually, it's got several layers to it. One, we need to start connecting dots and telling the truth about what's happening across Louisiana, not just this coast, but also in the north and the west and the central parts of our state, our great state, and this whole southeast region. We've got to be honest about the root causes of this. I'm a child of oil and gas. I understand we can't all just go against the industry and the history, but there's a reality now, and we have to make a different choice. We have to. Our lives depend on it. And then we have to be honest about who are the major emitters and polluters. This is not just about what this one company is doing to our community. This is about what we as the United States are doing to the world. And one American uses as much energy as over 300 folks in Ethiopia. I mean, the amount of consumption that Dr. Oppenheimer was mentioning, I mean, it's like tremendous. We are responsible for this. Not just we're on the bad side of this, but we are driving this thing. And so we've got to be really honest about climate change. We don't have any more time for politics. We don't have any more time for personal hate. We don't have any more time for rhetoric and or propaganda. We've got to start telling the truth because Louisiana's future depends on it.
Thank you, Colette. Dr. Cole?
For people to be open-minded about change and people who talk about change, to be open-minded about diversity of thought and opinion, and understand that, sometimes when people are entrenched in the status quo, they may very well have a reason for wanting to be entrenched in the status quo, and that reason is usually financially motivated to their own benefit. And so just in having an understanding of that, and that the people who are trying to change the world for the better may understand science, facts, data, and to a very deep level, and are motivated by a genuine sense of purpose and wanting to do something meaningful, impactful that helps fellow human beings in our society.
Thank you, Dr. Cole. Dr. Bentley?
Well, engaging the community and voting have already been said. So I'll just say educate our children and our communities. But there was a question that was asked that we didn't get a chance to address about climate science and our K through 12 curriculum. I don't know the answer to that, but that certainly is a good way to start to spread the word.
Well, thank you all so very much. I will speak on behalf of my 9-year-old son, Isaac. He would tell you to donate to Team Trees, stop using plastic straws, don't use hot water when you're washing clothes anymore, and simple things like that you can do around the house and when you're out at restaurants. So thank you all so much. Dr. Oppenheimer, it was a true pleasure to have you here. We're so grateful to your global leadership and your dedication to Louisiana. It's clear to everyone we're at a critical inflection point, a moment where we still have choices about the future of our climate. We have opportunities to mitigate and to adapt, but this window will not be open forever. We have to start doing things differently now. We have to demand climate accountability from our leaders now. We have to focus our energy and our expertise and our influence on addressing the realities of climate change now. I hope you will share this sense of urgency, and I look forward to working together to build equitable, climate resilient communities in Louisiana and throughout our nation. Thank you for being here. And thank you again to our speakers, sponsors, and especially our attendees. If you are a certified floodplain manager, please fill out the survey that will appear when you close the Zoom window so that we can help you get continuing education credit. And please, everyone, don't forget to mark your calendars for the next session of the Smart Growth Summit Climate Week. On Thursday, we'll hear from Peter Calthorpe, Dr. Heel, Dr. Holder, and Dr. White Newsome, Climate and the COVID-19, the Diabolical Duo. With that, thank you all so much. It was a true pleasure, and we'll see you all again soon, hopefully in person.
Bye.